back in the groove a little bit today. I know it's going to be a little rough, right? But let's try to get back in the groove. So first off, I guess I should mention that next Friday, the 11th, is your semester exam. Okay, so next week we'll do some review to prepare for that. Okay, but first we are going to finish up the sequences and series chapter. So the last few days before break were map testing, but before that we were talking about sequences and series. So does anybody remember what a sequence is?
It's like the numbers that are added evenly. Like, I don't know how to explain it. Like, you get what I'm saying?
So you're jumping ahead. That's an arithmetic sequence. So just a sequence in general is just a list of numbers. So then we talked about one specific type of sequence, an arithmetic sequence. So in an arithmetic sequence, to get the next number, we added the same number every time, right? So like 1, 3, 5, 7, 9, that would be an example of an arithmetic sequence where we're adding 2 every single time to get the next number, right? So we can say an arithmetic sequence is a list of numbers. And there's a lot of ways that we could word this, right? But we can just say where we add the same number every time. All right? So today we're going to take a look at a new type of sequence. Right? We're going to take a look at what's called a geometric sequence today. So our definition for a geometric sequence is this. Okay? A sequence where the ratio between any two terms is constant. Okay? In other words, okay, you can put this in parentheses if you want to. Okay? Another way of saying this is we multiply by the same number every time. I'll give you a second to copy this down here. Okay, so again, we're just talking about a list of numbers. Right, but now instead of adding the same number every time, we are going to multiply by the same number every time to get the next term. And then that number that we multiply by is called the common ratio. Alright, so you could put this in parentheses down here again. Just say the common ratio is the number that we multiply by. Alright, so let's first then just take a look at some sequences and try to determine if they are geometric or not. Alright, so sometimes it's easy to tell just by looking at a sequence. Okay? Sometimes we'll have to do a little bit more thinking. The easiest way, the way that will work every single time to determine if a sequence is geometric, okay, we want to see if a number divided by the number before it is equal to a number divided by the number before it is equal to a number divided by the number before it. That's how we determine the common ratio. Okay, so what's 12 divided by 6? 2. Right? So what we can say is to get from 6 to 12, I'm multiplying by 2. What's 24 divided by 12? 2. Right? So I'm multiplying by 2. What's 48 divided by 24? 2. Right? So I'm multiplying by 2 to get the next term. Since that ratio, okay, that common ratio is constant, I'm multiplying by the same number every time, we would say that, yes, this is a geometric sequence. Right? Let's do a couple more together, and then I'll have you guys practice some. All right, so we want to do the same thing here. In order to figure out the common ratio, I take one of the terms and divide by the term before it. So what's 270 divided by 810? I think it'd be 1 over 3, right? Yeah. We take 270 divided by 810. Right, so we're always taking one number and dividing by the term before it. Right, so you would get 0.333333, or as a fraction, that would be 1/3, right? So that means 810 times 1/3 is 270. Okay, how about 90 divided by 270? I think that is 1/3 as well. And 30 divided by 90? So, I am multiplying by the same number every time to get the next number in the sequence. So this one is also geometric. Okay? So let's take a few minutes here and practice up through number 8. Right? We're just determining on all of these if these sequences are geometric or not. So all you're going to do is take one number, divide by the term before it to get the ratio between those two terms. Then do the same thing for the next set of terms. So here we would do 8 divided by 4, then 20 divided by 8, then 60 divided by 20, and see if that ratio is the same between all of those numbers. If it is, it's geometric. If it's not geometric. All right, so let's take a few minutes to try these here. Alright, I put the next two up here on the board. So I think in number 3, we are multiplying by -5 every time. Right, it's okay if it's a negative number, as long as it's the same negative number all the way through that we're multiplying by. So I think this one is a geometric sequence. On number 4, though, we are not multiplying by the same number every time. 4 times 2 is 8. 8 times 2.5 is 20. 20 times 3 is 60. So this one would be no. How about the next set of 4 here? Are we multiplying by the same number every time on number 5?
Yeah.
Yeah. And I think we're multiplying by
Negative.
-1/4 every time. So this one would be yes. How about on number 6?
No.
Right? Here I'm multiplying by 2, then here by 4. So already we can see it's no. How about number 7? Yeah, I think we're multiplying by 7 every time.
Yeah.
Right? So this one would be geometric. How about number 8?
Yeah.
What number am I multiplying by every time here?
2.5.
And that works out all the way through. So yes, this is geometric. All right. Questions so far? All right. Then let's write some rules for geometric sequences. So this rule right here can find any term in a geometric sequence. Right? We say any term is the nth term. So a sub n is a sub 1 times r to the n minus 1 power. Right? Where a sub 1 is the first term in the sequence, and r is the common ratio. Common ratio is just the number that we're multiplying by every time. Right? So those are the only 2 pieces of information I need to write this rule. I need the first term and the common ratio. Right? So jot that down here. And we'll take a look at some examples. So for these sequences, we'd want to first write the rule, and then I think I put on there find the 10th term, right? Yeah. So my rule is a sub n equals a sub 1 times r to the n minus 1 power. So the 2 things I need are the first term and the common ratio. What is the first term? 1, right? So I'll say a sub 1 equals 1. What's my common ratio here? 5. Right? I'm multiplying by 5 every time. So my rule then, this is all the information I need. Right? The first term and the common ratio. So my rule then is a sub n equals 1 times 5 to the n minus 1 power. Now, if the second part is to find the 10th term, I'm just going to plug 10 into this rule. So 1 times 5 to the 10 minus 1 power. It's going to be a pretty big number. Right, say it again.
9.
So numbers in geometric sequences can get pretty large pretty quick, because I'm multiplying by a number every time. So just up to the 10th term, we're already almost 2 million. So 2 parts to this answer. Right? The first part is the rule. The second part is the 10th term. Okay? All right, let's do one more together, and have you guys try some. So again, I need the first term and the common ratio. So my first term is obviously 130. What's my common ratio? 1/2. Okay? So to get that, you just take one term and divide by the term before it. Right? So 65 divided by 130 is a half. 32.5 divided by 65 is a half. So now I'm just going to take those two pieces of information and write my rule. So a sub n is equal to 130 times, I'm going to put this in parentheses. Whenever we have a fraction raised to a power, we generally put it in parentheses like that. Okay, so this is my rule. So now if I want the 10th term, I'll say a sub 10 is equal to 130 times 1 half to the 10 minus 1 power. So here, this is probably going to be a pretty small number. Right? If I'm multiplying by a half every time. So what is my 10th term here? That's
0.253
Is that what everybody else got? Questions? All right, then let's take a few minutes here, and you guys try up through 14. Also, this arithmetic series practice paper, no name, has been up here for a while. So if you're missing that, check to see if that's yours. guys, remember that there are two parts to this answer. First part is the rule. The second part is the 10th term. Right? So if you only put the 10th term, you get half credit. That's an F, 50%. So make sure you're putting both parts of the answer. Alright, it looks like we're getting pretty close to done. If you're not quite done, that's alright. Keep working, finish up the last one or two you're on, but start going over them here. So I put number 11 up here. I think our rule should be a sub n equals 2 times -4 to the n minus 1 power. So then if we plug in 10 for n, we get negative 524,288. All right. Then number 12. Looks like my first term is 8, and my common ratio is 3. So my rule then would be a sub n equals 8 times 3 to the n minus 1 power. If I plug in 10, 8 times 3 to the 10 minus 1 power, what do we get for that?
Negative 524,000. 17,496.
17,496. Is that what everybody else got? No. What everybody else got? That does seem a little low. What do we get?
157.
What was it? 157. 464. That look good? number 13. So here we are decreasing. So my common ratio is going to be less than 1. Let's see, what is it? 2/3. So my rule is 135 times 2/3 to the n minus 1 power. So then if I want the 10th term, 135 times 2/3 to the 10 minus 1 power gets me what? .51. Is that what everybody else got? What? How far does it go out?
It's
6,
another one.
5, 9. What was it? 808.
Could we just go to the nearest one? Or do we have to write all of those out?
On these, I want you to write it all out because on some of them, especially on ones like this where they're going to keep getting smaller and smaller and smaller. I mean, we might have to go out to like the 6th decimal place to even see the difference between the number and the next number. So on these, I do want you to write them all out. Okay, we okay on this one? All right, and then the last one. Let's see, my first term is negative 3,200. My common ratio would be negative 1/4, right? So then my rule would be negative 3,200 times negative 1/4 to the n minus 1 power. So then the 10th term, negative 3,200 times negative 1/4 to the 10 minus 1. What does that get me? .012.207. So you get pretty small pretty quick. Questions on these? All right, then we've got one last set of problems here. On these, the directions are pretty much the same. Right? It says find the rule, and then this time it's not just the 10th term. We might have a different term here. In this case, it's the 8th term. So the goal is the same. Right? For all of these, I need to find first term and the common ratio. Well, in this one, I'm just given both of those pieces of information. Right? I'm just given that the first term is 7. And I'm given that the common ratio is 4. Those are the only two things I need to write the rule. So what does my rule look like?
Seven times 4. And then Eric, whatever it's called, 3 times 1. Like 8, I'm sorry.
Yeah. So first, our rule, we would put the n minus 1, and then for our 8th term, we'll plug in 8. So 7 times 4 to the 8 minus 1 power. So what do we get for our 8th term here?
1,600.
So this one was pretty easy. Right? We were just given the two pieces of information we needed, plug them into the formula, and we're good to go. So on the next couple, though, we are not just given those pieces of information that we need. Okay, on this one, what I'm given is the fifth term and the common ratio. And using that, I want to find the first term. I want to write the rule and also find the first term. Well, what we're missing, obviously, in this formula is the first term. So, any ideas on how I'm going to use this information and this formula to find the first term? Any thoughts? So we can plug something into this formula in every spot except for a sub 1. Right? We have all of that information. Here, my a sub 5, I'm going to treat that as my a sub n. So I'm going to say that 5 is my n value. Then my a sub 5, my a sub n, is negative 68. So what I'm going to say, my a sub n is negative 68. So I'm going to say negative 68 equals a sub 1 times r. I know my r. My r is negative 0.5. And then we just said that n was 5. Right? So I'm going to say this is to the 5 minus 1 power. Well, I can solve this now for a sub 1. What's negative 0.5 to the 5 minus 1 power? Say it again. 0.625. Okay, so now my formula is negative 68 equals a sub 1 times 0.0625. How do I solve for a sub 1? If I'm multiplying a sub 1 times this number, how do I get a sub 1 by itself? Divide. Yeah. I'm just going to divide both sides by this 0.0625. So over here, those cancel out. What's negative 68 divided by 0.0625?
Taking approximately 1,088.
So that is my first term. Negative 1,088. My common ratio was negative 0.5. So we've answered half of the question, right? Half of the question was to find the first term. The other half was to write the rule. So we still have to write the rule. So now I can just plug these two pieces of information in and say, excuse me, say a sub n equals negative 1,088 times negative 0.5 to the n minus 1 power. Okay, so again, make sure that you are answering both parts of the question. Make sure you are writing the rule. It still has an n in it. And then finding the indicated term. In this case, it was the first term that we were looking at. All right. Feel okay so far? Let's do one more together here.